Okay, so we've looked at different integrals where the improper part has gone to either infinity or negative infinity or both at the same time. But what happens if we're not continuous somewhere on our interval? Well, when that happens, then what we're going to do is instead of looking at a situation where we change our integral to go from 0 to infinity and change that infinity to a b, what we're going to do is we're going to now approach that point of discontinuity from the left and from the right. So if we have a situation where that happens, then we just alter our integral a little bit and we change our limit a little bit to match the situation that we need. So if we're approaching a vertical asymptote, then we look at what's going on from the left and from the right, and we see if there's a limit that we can get out of that. So if you have a situation where we've got that, if we have that spot on the interval that we're interested in and it's discontinuous inside, then we have to break our integral up into two pieces. And this is similar to the improper integral that went from negative infinity to positive infinity. Okay? Well, that's exactly how we start with our first example here. We've got the integral from 0 to 3 of dx over x minus 1 to the 2/3 power. The problem is, if you look at x minus 1, that equals 0 when x equals 1. That's on that interval between 0 and 3. So what we have to do is break this guy up into two separate integrals. And we're going to look at the integrals this way. We're going to look at the integral from 0 to 1 of dx over x minus 1 to the 2/3 power plus the integral from 1 to 3 of the same thing. Okay, and so what we do with this situation is now we go, okay, we can't really put a 1 in here at all because that gives us an undefined situation. We can't put 1 in here because that gives us an undefined situation. So we look at the limit as x approaches 1 from the left, okay, because we're on the left-hand side of that. And actually, I'm going to take that x off and make it a b. So as b approaches 1 from the left, and then we can look at our integral now from 0 to b of dx over x minus 1 to the 2/3. Okay. On the flip side, over here, we would have the limit as c approaches 1 from the right, because now we're on the other side of that guy, of the integral from c to 3 of the same thing. Okay, and we're gonna add these two guys up. So this is what we're working on. This is the thing that we're going to integrate. And we really just need to integrate it one time. Now, we have to handle our 0 to b and our c to 3 parts separately. But basically, what you're integrating is, if we just think about this in general terms for just a second, I'm integrating the integral of, watch this now, x minus 1 to the negative 2/3 power dx. Okay? And with that just one x in there, all we have to do is add 1 to the exponent and divide by the new exponent. Okay, that's all we have to do. Now, if this said 2x, we would have to do a u substitution. But on this guy, what we're going to end up with is x minus 1, and then add 1 to your new exponent, which makes it the 1/3 power, and divide by 1/3. So remember, when you take that step, you're actually multiplying by the reciprocal. So both of these integrals are going to pop out as 3 times x minus 1 to the 1/3 power. Both of them do. Now we just have to do the math part, which is stop minus start. So I'm going to have to get creative with my space. I didn't leave myself a lot of space to work here. So what we'll do is we'll take this guy and we'll work him over here. So I'm looking at the limit as b approaches 1 from the left of, and then my integral, which is going to be 3 times x minus 1 to the 1/3 power, evaluated from 0 to b. So I do stopped minus start. That's going to be 3 times b minus 1 to the 1/3 power minus 3 times 0 minus 1 to the 1/3 power. So the cube root of negative 1 is negative 1. So negative 3 times negative 1 makes that positive 3. All right. And then as we get close to 1 here, okay, remember we're approaching 1. Well, I can put a 1 in for this guy. And 1 minus 1 is 0. So this is going to be 0 plus 3. So the first limit goes to 3. I'll do the second one right here. I think I'll have just enough room. That's not a different enough color. So the second guy is going to be the limit as b approaches 1 from the right of the same thing, which is going to be 3 times x minus 1 to the 1/3 power. And now we're going to evaluate this, though, from c to 3. And so when I do that, I get 3 times stop, which is going to be 3 minus 1 to the 1/3 power, minus 3 times where I started, which is c minus 1 to the 1/3 power. Okay, so 3 minus 1 is 2. So we're looking at the cube root of 2. Well, I don't know what that is, but I'm going to multiply it by 3. So I got 3 times the cube root of 2. And then when I put a 1 over here, that's going to be 0 again. 1 minus 1 is 0. Cube root of that is 0. So there's my second part. All right. So what do? I add these two guys together. And when I add my first part, when I add this with this, that will give me the answer to my problem. So what is my answer going to be? My answer is going to be 3 plus the cube root of 2. 3 times the cube root of 2. So there's a few steps in here, but again, it's using those same properties of limits that we used on the other improper integrals that we were talking about on some of the previous slides. So just be patient, use what you know, take advantage of the things that you know. When you can substitute a 1 in and get a real number like 0, that's fine. But if you have a situation where you have an indeterminate form, look for L'Hopital's rule. But one step at a time here, one algebraic step at a time, and the calculus will take care of itself.